Hi, everyone. I'm Dave Mariani. I'm the CTO and co-founder of AtScale. And today I'm going to take you on a journey. It's going to be a live journey. So I'm going to show you software. I'm going to talk about concepts like the semantic layer, and we're actually going to see it in action. So let's get started. So let's get started first with just a few slides, just to talk a little bit about the semantic layer and why you should be interested in the topic. If you're, if you've heard or heard about DBT and DBT semantic layer, you know that semantic layers are becoming sort of a hot topic in analytics, and becoming really a critical part of the stack. So what we're going to do in this presentation is that we're gonna talk about what it is, why you need it, where it fits, and then I'm gonna show you how we actually use a semantic layer to actually consume data both from a business standpoint as well as a data science standpoint. So let's just start with some definitions. The semantic layer is, and I just pulled this one right off of Google just by searching for semantic layer. And of course, it ended up on Wikipedia. I thought that they did a really good job at defining what a semantic layer is, so I'm going to use it. The bolding is not mine, that's theirs. They also did a good job at bolding. So let's pick this apart for a second because there's a lot of words here. A semantic layer is a business representation of data, and that's really key. It's a logical view. Some people call them metrics. I call it a semantic layer, and the difference is that it's not a technical layer. So you have databases and you have database tables, and that's really suitable for data engineers and people who understand how to write SQL. But that's not the majority of everybody out there. Most people just want to consume data in terms that make sense to them. And that's really the second part of this statement. It helps users access data autonomously. That means self-service. You can't really truly have self-service if your terms of self-service are that you have to be a database engineer. And that's kind of where we are today, right? Without semantic layers, we force users down the path of with modern visualization tools like Tableau and even Power BI, and we really force them to create models before they can actually create their dashboards or their reports. In the case of data science, we force a data scientist to go and write a bunch of code to fetch the data and to clean the data before they can actually start to train their models, or create new insights. So it's really, really we don't truly have self-service today. We have self-service for the few. And then the last part of this is common business terms. And today, the business runs on metrics and they run on KPIs. Those KPIs are up to interpretation by anybody who has either a Jupyter notebook or a BI tool, or even who can write code. So that's a bad state, and having a lack of consistency when it comes to the business is a real problem. So I'm the co-founder of AtScale, and the idea for AtScale really came out of my experience running analytics, and the analytics operations for Yahoo. And what I had is what you see on the before side. I had many data platforms or data sources. We had Oracle Data Warehouse that was gigantic, biggest one on the planet probably at the time. That wasn't big enough. We had data marts because business units didn't want to wait for the data warehouse. And then we invented Hadoop and the data lake, because it was important not to throw data away and have a more inexpensive way of storing and capturing that data. That really made it my life more difficult because I had to then feed what you see up on top here. I had Tableau users, I had Excel users, I have ClickView users, I had MicroStrategy users, and they all needed basically the same data, but sliced in a different way for those different tools. And then I had my data science teams, Yahoo Labs, which is 1,500 people. And the common refrain there was, we can't get access to data. And my whole point would be, oh, well, look, here's Hadoop right here, right? Go for it. No way. It's just too hard to get access to, and nobody wants to understand where the data is, how it's stored, or what it means, or how to put it together. So what you see on the right is what I wanted as the chief data officer at Yahoo at the time, but I couldn't have. And I wanted a semantic layer where I could consolidate all my business logic in one place, be able to hide all the complexity of where the data was stored, because there's just no way we live in a world where data comes from one place. And also be able to serve my business units and my business people and my data scientists with the tools that they wanted to use. So, our up until this point, it's a lot of people think that they can force a single way of consuming data on their audience, and that's just not true. Sometimes finance, the best tool for the job is Excel, and for marketing, it may be Tableau. And for your data scientist, it's an AutoML platform, or it's a Jupyter notebook, and it's Python. So you got to go and take and allow people to get access to the data where they're playing, and that means that it has to be the semantic layer needs to be able to accept and work with all those different tools, or else it's useless. It's not worthy at all if not everybody's going through the semantic layer. So the other thing the semantic layer does is that besides that consistency of the business rules and business logic, it also gives you the control. Because if now everybody's consuming from the semantic layer, you can apply governance in one place. There's no need to apply some other sort of governance tool on the side. You can have one place to gate who sees what and when they see it. And then when it comes to agility, if I don't have to actually create data sets and create data extracts for all these different tools, like I had to at Yahoo, where it took me literally 3 months before I was able to deliver a new data set. With the semantic layer, I can do that instantly. Not instantly, like in a few hours and in a few days, but it's much more quick. It's much easier to introduce new data and have it be consistent and trustworthy for this audience, because I don't have to worry about people getting access to data that they shouldn't have access to. So that trust allows me to be much more free with which data I make available to my audience. So where does the semantic layer fit? And I'm going to show you this live in a minute. So bear with me. It sits in between the consumption and the people consuming data, as well as the data platforms themselves. And that's really key because because the data consumers, first of all, they come in different flavors, and they're speaking different languages, by the way. So your business analyst using Power BI, they want to speak DAX, the DAX protocol. They don't want to speak SQL because that's because Power BI is actually terrible at SQL and not performant at all. In your Excel users in finance, they want to have a live connection using Excel. And getting data in Excel today means dumping data from a BI tool or some other terrible mechanism where now you've created a separate static copy of the data with no control. That's not good. You need to have a live connection, and Excel wants to speak MDX. Tableau is excellent at SQL, as is Looker. And so they need a SQL interface to the semantic layer. What about you and the data scientists out there? Well, you need SQL access, but you also need Python access. You also need it to work with your AutoML platforms, wherever they may be. And if you're an application developer, well, you're going to code either using REST or you're going to be writing database queries using ODBC and JDBC. So you need to get access to data using those tools. So the first point I want to make is that a semantic layer needs to be truly universal, and it's universal in that you can speak multiple languages to it. So SQL is by alone is not enough. So any semantic layer that only has one way and one on ramp into data access is not going to do the job. Well, what about the data access? Well, this is the other part of it. We have data everywhere. I know we all want to have one data warehouse or one data lake. The fact is that data still is spread apart, and then we have data in SaaS applications that's locked away in proprietary clouds like Salesforce and ServiceNow. We need access to all that data. So whether you're in Snowflake or BigQuery or Redshift, whether you're using Databricks as your data lake, or Spark or Hadoop, or whether you're accessing SaaS applications, you need to be able to get access to that without forcing your users to know where to go or have to be able to log on to all those. The semantic layer creates that firewall where the users in consuming that data are agnostic to where that data is coming from. They don't care, and they should never care. That also gives IT and your data architects the ability to move data around and change things without breaking the front end, without breaking the thousands of dashboards or the hundreds of machine learning models that you have running out there. Why is a data catalog there? Well, the enterprise data catalog needs to interact and share metadata with the semantic layer, and it's a two-way street. And the semantic layer shares its metadata with the data catalog so that the semantic layer is searchable from the data catalog. The data catalog shares its metadata for the semantic layer, so we make sure those business terms are the same and defined in one place. So then how does this look in practice? Today, I'm going to show you what AtScale semantic layer does. And we've been at this for 9 years now. So we've seen and worked with a lot of enterprise customers and learned a lot during this time. What we've learned is that the semantic model is really the key to the kingdom. What you're seeing here, and I'm going to show you this live, is what we call Design Center. What you see on your right, where my cursor is a preview of what the consumers are going to see. And you can see that there's simple business metrics. They're simple business terms. Has nothing to do with database tables. What you see on the left is database tables and relationships between those and between those data assets. So a data steward can be in the business. It could be somebody in finance doing a finance model. It could be somebody in marketing doing a marketing model. They're creating the map. They're creating this logical view, and they're creating it in a semantic model. And then your consumers can then consume that semantic model, and queries will be generated automatically against data platforms. So that's the Rosetta Stone, is that semantic layer. And I'll get into what it means for a data mesh style of analytics delivery in 1 minute. So then that's what the data steward sees. What does the consumer of that data see? Well, they see the same models. This is the internet sales model, and it's going to appear, of course, in different tools. It might look slightly different, but the names of it, the names aren't different. Neither are the hierarchies. Neither are the meanings. So everybody's going to be working with the same view of that data, and they're going to get access to that data without having to model it in their tools. It comes live like this, and it's all live access, by the way. It's not import. It's not extracts. That's evil. Don't do it. So what is a semantic layer used for? So these are kind of 4 use cases you can sort of think of. The first one is what a lot of companies are doing. A lot of them have already done it. They've moved their analytics operations to the cloud, and they've consolidated their operations on a cloud data warehouse like a Snowflake or data lakehouse like a Databricks, for example. Well, when you do that, you need to be able to manage access to those assets, and a semantic layer is an excellent way of doing that. Not only is it governing access to that data, it's also accelerating access to that data, and as well as saving cloud costs by avoiding repetitive queries. And you're going to see how that happens live in my demo. You also, lots of people are talking about metrics and metric stores. This is what dbt is talking about. And yeah, it's a semantic layer is a metric store. It allows you to be able to have a single source of those business and enterprise metrics for both your AI and BI users. And it does a wonderful job at bridging the gap between the data scientists and the business analysts. Why? Because a semantic layer can be consumed by both a data scientist and a business analyst. And what's great about being a data scientist is that you could actually write back to the semantic layer, at least the AtScale semantic layer. That means you can create new predictions and new features. Write those back to the semantic layer so they can be consumed by the rest of your teams, not just your fellow data scientists, but also your business analysts and those application developers. So what does that mean? That means I can start with historical sales, for example, and I can now have my data scientists forecast my sales in the future. And I can look at historical sales and forecasted sales along any dimension and along any time frame, all within the same semantic layer. And the users don't have to care where it came from or how it got there. The last one is about OLAP modernization. OLAP is a dirty word. It's a dirty word because people, OLAP tools traditionally create cubes, which means they take data out of its source and create a separate copy of it that's optimized for query. Well, that's the bad part of OLAP. The good part of OLAP is it's lickety split and fast, and it's really easy to use. So with a semantic layer, it can give you, and the proper semantic layer like AtScale, it can give you both. So you don't have to give up all that dimensional access to be able to run queries in the cloud. So let's talk a little bit before I get into a demo here about different styles of analytics delivery and this hot topic of data mesh that a lot of people are talking about. So this was me at Yahoo. I ran the central data team, and then I doled out data with my data engineers to my different business teams. And what was hard is that I needed really to have a lot of interaction with those business teams, because me and my team, we didn't understand finance, we didn't understand sales, we didn't understand marketing. There's no way we can understand every business domain. And so that made for things that were pretty slow, because my finance users had to explain exactly what they needed and explain how to calculate what they needed. And then I had to have my data engineers write that for them. That's not very agile, and it's not very efficient either. A data mesh style of analytics organization says let's decentralize the data product creation, and let's let those teams themselves create their own data products and then share it with each other. Because why wouldn't finance build a finance data product? Because they understand finance, right? Well, the problem with that approach, and where the data mesh doesn't go far enough, is it doesn't really talk about the tools that you would use to do that. Because if everybody's doing their own thing and using their own set of tools and their own set of applications and products and tools to create those data products, it means those arrows between these different business groups, it's just not going to happen. It's not going to be possible. It's a Tower of Babel. Everybody's doing their own thing. And I really don't like that about data mesh. And I think that data mesh can really work if you add on top of it a semantic layer, because then the semantic layer can be the form of sharing. It could be the form of communication, because the semantic model is the Rosetta Stone. So let's just take a look at how that might work. So here are my 4 groups. Of course, there's more than this. This is just an example. And I still got my data team. Hey, the data team is not out of the equation here, not at the least. There needs to be some organization who is at least documenting the rules of the road. There should be some technical team who's just deciding what tools people should be using, and be able to also manage that semantic layer platform. So what could happen? So you could have a central data team contributing really important assets like a time dimension. And so everybody needs to be able to speak of time and talk about time and roll up time the same way. At Yahoo, this was a real problem because we had impressions and we had clicks, and everybody rolled up a click and an impression in a different way in their own tool. And nobody could decide how many clicks we served yesterday. And that was really, really frustrating for everybody, including myself. So with a data team can create a time dimension, for example, and then the marketing team can create their own campaign dimension, because of course marketing understands campaigns and what the different attributes our campaigns are, but they can use that time dimension and connect it to their campaign model along with their campaign dimension. So now they have a way of expressing campaigns over time. Again, a super simple model. The sales team can do the same with their sales ops model. Again, they can contribute, they can use what's already been done by the data team and build their sales ops model. The finance team is building cost models for everything under the sun, and they are also using that time dimension. But what's going to happen when the business needs to ask the question of, what is my ROI by marketing campaign? Well, I need data from finance and I need data from marketing. Well, with a semantic layer platform, you can then combine those models together, the cost model and the campaign model. And now you can have a campaign ROI model, and you don't have to reinvent the wheel. So what this does is that the semantic model allows these data stewards to encapsulate their knowledge in a model and then share that, or a dimension, conform dimension, and then share that with the other teams and be able to have ownership over those assets. And they can decide what gets shared and what doesn't get shared. So it does become a model. It becomes an organization that can truly work. That's the best of both worlds. It allows your domain owners to take their domain knowledge in finance, sales, marketing, et cetera, and apply that and build products. But those products could be shared and combined with other teams' data products. Okay, I'm going to show you that. I'm going to show you how that works live. And so what I'm going to show you is I'm going to go through a very quick demo where I'm going to create a new model on the fly. I'm going to be using today it's a web store. It's a bike shop. I'm going to be creating a new model, and then I'm going to be consuming it using Tableau, Power BI, Excel, and a Jupyter notebook. And if I have time, I'll also even show you what it looks like as from an application developer as for how I would actually write that code through JDBC or ODBC. Okay, so let's get going. Okay, I got about a little more than 15 minutes left. Okay, so what you see here is this is that picture you saw. This is what the data steward's view is. So in this demo, I'm going to be playing two roles. I'm going to be playing the role of the data steward, where I'm going to create the model that you see here. And then I'm going to play the role of the data consumer, where I'm going to go and use those different tools to access this model. So what you're seeing over here on the right is a preview of our internet sales, like you saw in that screenshot. And you can see that we have folders, and we can have different metrics as well as different dimensions in these folders, and different ways of rolling up or rolling up data into different hierarchies. So it's a truly dimensional model. So let's go and let's head back to and let's create a new model, and I'm going to call it DSC 2022, and I'm going to come into my model canvas. So the first thing I'm going to do in my model canvas is I'm going to go and fetch some data. So how does that work? Well, I have a bunch of data assets here. You can see I have data in Snowflake, Databricks, BigQuery. I'm going to be using BigQuery today for my demo. And you can see I can, just by clicking here, I can see all my data assets in my projects, in my databases, and I have all my tables here. This doesn't have to be encoded. All you need to do is establish a link to those data assets, and then your data stewards can just go ahead and pull on the data assets onto their canvas to model. Now, they're only going to be able to see the data assets they have access to, by the way. So I pulled on this sales log table. This is a table, and I can do a preview of it, and you can see my data. This is a preview of what it looks like. And you can see this is a transaction table. So I have order numbers. So it's at the granularity of an order, which means it has all the items in it as well. And it's as messy as data can get. You see I have some nulls over here. Well, I can go ahead and clean those up right now. And I'm just going to wrangle this and clean that up by replacing those nulls with an unknown value. At least it will look better and operate better. So this is like a transform that's a virtual transform. So we're not creating physical transforms here. We don't need to. We can operate and create a model on top of this raw data without having to create a traditional star schema. It's not necessary. We can also add calculations, and I'll add a new calculated column called sales tax. And I'm just going to write a formula, and AtScale is going to help me write that formula. And this is just a snippet of SQL. So there's no new language to learn here. I'm going to be able to use the native capabilities of the data platform I'm talking to. So that means anything that's available, in this case in BigQuery, and any stored procedure, or sorry, any UDF, user-defined function, any of the capabilities I can use, which means it can do anything. So you can see I have sales tax now. I'll go back to my canvas and you notice that sales tax is now part of this, what we call a data set in AtScale parlance. So we turn this table now into a data set that includes data from the table as well as calculated columns. Okay, I'm gonna move a little faster now. I'm gonna create sales tax and I'm gonna turn it into a measure. I do that by dropping it on my measures panel. And AtScale is going to do a bunch of things. You can see there's a bunch of different ways I can aggregate that data. I'm just gonna let AtScale figure it out for me. And I now have my very first metric in my metric store or my semantic layer. It's called sales tax. Let's add another couple. I'm gonna add my order quantity. I'm also going to put it into the same folder I did for sales tax. I definitely going to want to know how much each basket or order value was. So I'm going to put in my sales amount in there. And now I have my first three assets there, my first three metrics. So now what would this be? How would this work in a data mesh style? Well, gosh, I know that I want to be able to report these sales by customer. I want to have a customer view. I obviously want to do it by time. And I'm a retailer, so I have a special retail calendar. And I'm also going to want to do it by a product and look at it by products, but I don't know what the product hierarchies are. All I have here is the SKUs. So how am I going to get that? Well, because I can use my library here, and because other data stewards or that centralized data team created these assets for me, these models for me, I can just use them as is. So I can just go ahead and drag in these three assets here, including my date dimension here. And what I have is I have my customer and my product and my date dimension. Now, watch what happens. To be able to link these up to this new model I'm creating called DSC 2022, I just need to link them up. So watch what if I take the customer key and I link it up to the customer key here on my dimension. You see, as you see over here, I've now got all these assets, including where my customer lives, both rolled up by city, state, country, as well as by zip code. So why did I get all that? If I just double click on this to drill down on this model, I see that this model called customer dimension is made up of another canvas with a bunch of other models, not a bunch, two other models, including my geography dimension. And so I built models upon models. So these are like Lego building blocks. And now what you see here is I also have a row level security dimension. So I'm able to actually filter people by their location dimensionally. And that's really a great way of providing row level security. We also have column level security through perspectives and everything else. Okay, so let's go back to my main canvas. So that you saw here, now I got my customer data. So let's go and let's take and pull in my the rest of what I would do. Let's hook up my product dimension. And now I got my product data here. You see it right there. And then let's go and do the same thing for dates. So we have a couple dates here. We have an order and we have a ship. So how do I deal with that? This is what's nice about semantic modeling. You can take my order date key, and if your semantic layer supports it, I can have a role-playing dimension here. So let's do the same thing with ship. And you notice I'm putting just a prefix in there. Now, what happened over here in the dates? Well, now I have inherited the hierarchy, all my hierarchies for order date, and I also have the same thing for ship date. So now my users can look at their orders by order and ship dates, and I didn't have to do anything other than creating that connection, creating that relationship. So what about nested data? Well, the world is really built on nested data, isn't it? And in the case of AtScale semantic layer, we understand nested data. In this case, I'm taking some key value paired data in a string field, and I'm parsing it out and pulling out the color and the style keys in that key value pair field. And I'm just going to dimensionalize them by putting them into my dimension panel. And I don't have to call IT. There's nothing I need to do in terms of creating dimension tables for this. All I need to do is just do what I just did. So now I'm ready to really start to query this model. So I'm going to go and I'm going to make this available for query. And the way that we do this in the AtScale semantic layer is that we publish the model. So publishing the model simply is saying, okay, push it to production, and then make it available for consumers. And now you see my DSC model is now published, and now it's ready for anybody to consume. So at this point, I'm going to take my data steward hat off. So I'm done being the merchandising team right now, and I'm just going to be a business analyst who wants to look at my sales data for my web store, and figure out where we're making money. So I'm going to do that, and I'm going to do that by connecting, and I'm going to connect first to Tableau. So let's do this. I'm going to start with Tableau, and I'll move through the BI tools, and I'll show you what it looks like from a data scientist perspective in a Jupyter notebook. So hold on there. So I'm going to log in, and as a consumer, I'm actually going to log in using my Active Directory credentials, because I want to show you how the data governance works. So of course, my name's not Joe, but in this environment, I'm logged in as Joe. So we're going to see, I'm going to run some queries as Joe, and then I'll log in as me, David, in my other environment. So what you see here is you see our model, DSC 2022, and then this is the metrics we just created here. There's order quantity, and there's my sales tax. Remember, that was a calculation. So I'm just going to go ahead and start running some queries. So as a data consumer, I might want to see, where are my products selling? And I want to see that by my product name. Of course, these are products that have rolled up SKU level. So that's done. That was done for me by the model. Now I can see which products are selling the best. Looks like I'm selling a lot of tire tubes and a lot of logo caps. Let's now see where my products are selling. So let's go back to that customer dimension and see where my customers live. Let's first start at the country level. And you can see my breakdown of sales by country here. Now you see that I'm only seeing Australia, France, Germany, and United Kingdom. That's because I defined Joe to only see non-North America. So let's go ahead and let's drill down in those in these European and non-North America cities and states, and I can drill all the way down and see by region. And that was a very natural drill down. Why is it a natural drill down? Because the hierarchies are built in. This is a dimensional model. Now, what about those key value pairs? Remember I had color and I had style. Let's look at those. I didn't have to do any kind of parsing. It did it. The semantic layer did that for me. And now you can see my breakdown of by product color. And lots of products don't even have color as an attribute, which is why you see a lot of nulls there with no product color. Okay, let's now see what this looks like in a different environment. So I'm no longer a Tableau user in marketing trying to figure out where my products are selling. Now I'm a finance user and I'm in Excel. So what is a finance user going to do? Well, you know what? They're going to want to get live data, and they can do that without having to have an add-in or another product to install on their desktop. Anybody with Excel can do what I'm about to do because they're going to use the built-in analysis services connector. This is where the MDX, where Excel is going to speak live MDX, and I'm going to Windows authenticate here. And so I'm going to look at my project there. There's DSC 2022. That's what we just created. And I'm going to create a pivot chart to start with so you can see how that works. And I'm going to see the same semantic layer. There it is that I saw in Tableau. And if I go and I run that query of order quantity by color, I'm going to get the same answer, but now I did it live in an Excel worksheet that I did in Tableau. Same answer, same data, same governance for who I am. Okay, what about Power BI? So you got a lot of Power BI users out there, and they're going to want to do it and also get access to that data. Now, traditionally, what these Power BI users are going to have to do is that they're going to have to check this import button here. You notice how we default to connect live? Semantic layer really only makes sense if you're connecting live. If you're forcing users to import data into Power BI, you've lost your governance, and you've now turned your Power BI user into a data analyst, to somebody who understands how to model data. You've turned them into a data steward. So now they have to be both a data steward and they have to be a visualization expert. That's asking a lot. In this case, you see there's my model, there's my metrics, and I don't have to be a data steward because all I need to do is to use Power BI for what Power BI is good for, which is creating my visualizations. Again, what you see is what you get. And if I look at my model view in Power BI, you can see that the model is inherited because why? Because we're speaking DAX. And because we're able to speak DAX, we're able to get that for free. If I couldn't speak that, I would have had to spend, 10, 20 minutes at least to be able to create that model here by scratch. And it would mean that it would be a model that would only be resident in this workbook that's going to be different than my neighbor sitting to my left or my right. So what does this look like from a consumption perspective, from a data scientist perspective? Well, in a data scientist, for example, you work in a Jupyter notebook. So this is a sample Jupyter notebook we have here, where we're going to generate a forecast of sales and then write it back to that model you just saw. I don't have time to run through it because we're running out of time, but I'm going to show you how it all works. First of all, you just need to pip and install the AtScale Python library. Again, we're speaking the language of the consumer. In this case, it's Python. And we're going to go ahead and we're going to connect to a model. So you can see we're going to connect to the model. That was the same endpoint that you saw me use for Tableau, Excel, and Power BI. And once I connect, I'm going to select a project. You saw me do that in those tools, and then select the model. And then once I've selected the model, I can then fetch data from that model. In this case, I'm fetching categories here, and I'm fetching dimensions. I can do the same thing with metrics that you see here, and then I can get data and filter it, as you can see here, all done through the semantic model. So I don't have to worry about what is total units sold. That's already been defined for me in the semantic layer. I can get right busy generating my time series features and then building my predictive model to calculate forecast sales. And then look what I can do. I can then take that prediction and I can write it back to the model. So using the Python library, the AtScale Python library, you can then write back and you can see that we're joining on these features with that prediction. That means I'm going to be able to forecast sales by item, by state, and by time. And I can do that all within a Jupyter notebook. So my fellow business analyst that's sitting next to me, when they go and refresh Excel or refresh Tableau, they're going to see a new metric called predicted sales or forecasted sales. So let's just bring it all home. So I hope that that gave you a sort of a good view of just how it all works and how it holds together. So why do you want to have a semantic layer? You want to have a semantic layer because you want everybody speaking the same language. You also want it to make data available for everyone to make decisions. My motto is data for everyone, not just data for everyone who's worthy. And it's like anybody with Excel and Excel workbook, Excel on their desktop should be worthy of asking questions of their data. I think the semantic layer is a real critical component of a data mesh organization style, and I think it's critical. I think if you want to do one without a semantic layer, you're likely to fail in that endeavor. And a semantic layer is data governance. So you don't have to worry about purchasing a separate data governance package. And if you're IT out there, it future-proofs your choices because you have that firewall in between your consumers and your data, which allows you to plug in different types of consumers in the future, as well as move data around between different platforms in the future. So with that, we're at time. I want to thank you for joining us today and for this presentation. Go to atscale.com if you want to learn more about a semantic layer. So there's lots of guides there. I really want to thank you for spending the time with us.